The morning of November 14th, 1943, brought Lieutenant Klaus Hartmann to a muddy field outside Kummersdorf, where something impossible sat, waiting for him. The captured American vehicle looked insignificant, almost toy-like compared to the German military trucks parked nearby. Yet, the field report from Army Group Center claimed this machine had accomplished what no Wehrmacht vehicle could match. Hartmann circled the Willys MB Jeep, his boots squelching in the thick November mud. Water pooled in deep ruts that crisscrossed the proving ground, the kind of terrain that turned German reconnaissance missions into nightmares every autumn on the Eastern Front. The American vehicle bore the scars of combat, its olive drab paint chipped and scarred, but its engine sat silent and ready, recently abandoned by Soviet forces who had captured it from American Lend-Lease shipments. Oberleutnant Werner Schmidt, a mechanical engineer who had spent a decade designing suspension systems for Opel before the war, climbed beneath the Jeep with professional curiosity. What he saw challenged everything he understood about automotive engineering. The suspension was crude, almost primitive. Solid axles front and rear, simple leaf springs, no sophistication whatsoever. Yet, intelligence reports insisted this vehicle could carry 800 pounds across terrain that stopped German Kübelwagens dead. Schmidt called to his team of Wehrmacht mechanics and engineers who had gathered at the Kummersdorf vehicle testing facility. We need to understand what makes this machine work. The reports from the front are too consistent to dismiss. American and British units are maintaining mobility in conditions that leave our forces stranded. Within hours, a comprehensive examination began. The German team, led by Hartmann and Schmidt, approached their task with methodical precision. They measured every component, photographed every system, and documented the Jeep's specifications with Germanic thoroughness. What they discovered would fundamentally challenge German assumptions about military vehicle design. The Willys MB weighed 2,453 pounds empty, according to the data plate riveted to its frame. Its engine, a 134 cubic inch inline four-cylinder, produced a modest 60 horsepower. These numbers seemed inadequate by German standards. The Kübelwagen, Germany's equivalent light reconnaissance vehicle, weighed 725 kilograms. Over 600 pounds lighter, logic suggested the lighter vehicle would excel in difficult terrain. But logic, Hartmann was learning, did not always align with battlefield reality. According to reports preserved in Wehrmacht vehicle evaluation archives, American units were using these Jeeps to haul ammunition, wounded soldiers, and equipment across mud so deep it swallowed horses. Soviet commanders who had received thousands of Jeeps through Lend-Lease reported operational capabilities that seemed exaggerated, almost propagandistic. Yet, the vehicles kept appearing in intelligence photographs, deployed everywhere from the frozen marshes of Leningrad to the dust of North Africa. Schmidt spent 3 days examining the Jeep's four-wheel drive system. German engineers had considered four-wheel drive for the Kübelwagen during its development, but rejected it as unnecessarily complex and heavy. The two-wheel drive Kübelwagen, with its flat underbody and light weight, performed admirably in testing. It could slide over snow and sand like a motorized sled, its rear-wheel drive and limited slip differential providing adequate traction. The American approach was entirely different. The Jeep's four-wheel drive system was unsophisticated, but brutally effective. Power flowed from the engine through a 3-speed transmission to a 2-speed transfer case that could split torque between front and rear axles. There were no fancy differentials, no complex gear reduction hubs like those on the Kübelwagen, just simple, robust components that any mechanic could service in field conditions. There is no elegance here, Schmidt observed to Hartmann as they examined the transfer case. This is industrial design, not automotive engineering. But look at the strength of these components. The Americans have overbuilt everything. The 22nd of November, 1943, brought the decisive test that would either validate or disprove the American vehicle's reputation. Hartmann received orders from the Waffenamt, the Wehrmacht Ordnance Branch, to conduct comparative trials between the captured Jeep and Germany's own Kübelwagen. The test would be simple and brutal: load both vehicles with 800 pounds of sandbags and drive them across the muddy proving ground until one failed. The Kummersdorf testing facility had prepared a course that replicated the conditions German forces encountered on the Eastern Front every autumn and spring. Rasputitsa, the Russians called it, the season of mud, when roads became impassable rivers of churned earth. German military operations ground to a halt during Rasputitsa, waiting for ground to freeze solid enough to support vehicle traffic. The test course stretched 1,000 meters across a field deliberately flooded and churned by tracked vehicles. Mud depths varied from 15 centimeters to over half a meter in the deepest ruts. Stakes marked the route, but there was no actual road, just a morass of water-saturated clay soil that clung to everything it touched. According to documentation from the German Federal Military Archives, the test began at 0800 hours on a cold morning with threatening clouds. The Kübelwagen went first, its rear-mounted engine providing good weight distribution for its rear drive configuration. Schmidt drove, having logged thousands of kilometers in German light vehicles. He knew exactly how to handle the Kübelwagen in difficult conditions. The first 100 meters went well. The Kübelwagen's light weight allowed it to almost float across the surface mud, its narrow tires cutting through to firmer ground beneath. Schmidt maintained momentum, using throttle control and careful steering to keep the vehicle moving. The flat underbody lived up to its reputation, allowing the Kübelwagen to slide over obstacles that might have hung it up, but at 150 meters, the physics of weight and traction began asserting themselves. The 800 pounds of sandbags, concentrated in the rear cargo area, fundamentally altered the Kübelwagen's balance. The rear end began sinking deeper into the mud with each revolution of the wheels. Schmidt downshifted, trying to maintain forward momentum, but the Kübelwagen's 25 horsepower engine struggled against the increasing resistance. At 200 meters, disaster struck. The Kübelwagen's rear wheels broke through a crust of surface soil into deeper mud beneath. The wheels spun, spraying mud in high arcs, but the vehicle stopped moving forward. Its flat underbody, usually an advantage, now worked against it. The vehicle settled into the mud like a ship, taking on water, the cargo weight pressing it down until the undercarriage rested directly on the thick clay. Schmidt tried every technique in his considerable experience. He rocked the vehicle back and forth, attempting to build momentum. He engaged the low gearing on the reduction hubs, trying to gain traction through sheer torque. Nothing worked. The Kübelwagen sat motionless, its engine running but its wheels uselessly churning mud. Hartmann watched through binoculars from an observation tower at the course's starting point. He made notes in his field book, documenting the exact point of failure, the conditions, the load distribution. This was not unexpected. The Kübelwagen was never designed to carry 800 pounds across deep mud. It was a reconnaissance vehicle built for speed and efficiency with light loads on moderately difficult terrain. The test crew spent 40 minutes extracting the Kübelwagen using a tracked recovery vehicle. The German vehicle emerged from the mud like a sculpture, completely coated in clay. It had traveled 203 meters before becoming immobilized, less than 1/5 of the required distance. Now came the American vehicle's turn. Hartmann himself took the wheel of the Willys MB, wanting to personally experience whatever made this machine different. The Jeep sat heavier on its suspension than the Kübelwagen, its 800-pound cargo load barely seeming to affect its stance. The four-wheel drive system engaged with a solid mechanical clunk as Hartmann pulled the transfer case lever into low range. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Jeep's engine note was deeper, more substantial than the Kübelwagen's, buzzing four-cylinder. 60 horsepower compared to 25, but more importantly, all four wheels were driven, constantly pulling the vehicle forward. Hartmann released the clutch and felt the Jeep surge ahead with surprising confidence. The first 100 meters revealed the fundamental difference. Where the Kübelwagen had skimmed across the surface, the Jeep dug in. Its wider tires, 6.00 by 16 inches compared to the Kübelwagen's narrower profile, spread the weight load more effectively. But more critically, the front wheels were pulling while the rear wheels pushed. distributing traction demands across 4 contact patches instead of 2. At 150 meters, where the Kübelwagen had begun struggling, the Jeep simply powered through. Hartmann felt the vehicle lurch and bounce as its wheels found and released traction, but forward momentum never stopped. The suspension absorbed the impacts of hidden obstacles, the solid axles maintaining wheel contact even as the frame pitched and twisted over uneven ground. At 200 meters, the point where the Kübelwagen had stopped completely, the Jeep barely slowed. Hartmann maintained steady throttle, letting the four-wheel drive system do its work. Mud sprayed from all 4 wheels, but the vehicle kept moving with mechanical determination that seemed almost contemptuous of the terrain. Schmidt, now standing beside Hartmann's observation post, watched in silence that gradually turned into professional respect. At 300 meters, at 400, at 500, the American Jeep continued its steady progress across terrain that had defeated the German vehicle at 200. The cargo weight, 800 pounds of sandbags lashed to the rear cargo area and hood, barely seemed to affect the Jeep's capability. "This should not be possible," Schmidt said quietly. "The weight-to-power ratio is inferior to our vehicle. The suspension is primitive. The engineering is crude by our standards. Yet, it works." At 700 meters, the Jeep encountered the deepest section of the test course, where deliberate flooding had created a mud pit over half a meter deep. Hartmann felt the vehicle slow as all 4 wheels sank into the morass. For a moment, he thought the American machine had finally met its match. The engine RPM increased as the wheels spun, searching for traction. But then, something remarkable happened. The front wheels pulling from ahead found slightly firmer ground. The rear wheels, still in deep mud, pushed with the full torque of the low-range transfer case. The Jeep wallowed forward, almost swimming through the deep section, its 4-driven wheels working in mechanical harmony to maintain forward progress. When Hartmann emerged from the mud pit, he realized he had unconsciously held his breath. The Jeep had slowed to walking pace through the deepest section, but it had not stopped. It had not required recovery. It had simply worked its way through an obstacle that would have stopped any German light vehicle. At 1,000 meters, Hartmann reached the end of the test course. He stopped the Jeep, engaged the parking brake, and sat in silence for several moments. The vehicle's engine idled smoothly, its temperature gauge reading normal despite the sustained hard work. There was no mechanical distress, no indication that the Jeep had been pushed beyond its design limits. Schmidt arrived in a tracked vehicle, bringing recording equipment to document the test results. He walked around the muddy Jeep, examining it for signs of stress or damage. The suspension showed no deformation. The drivetrain components had not overheated. The 800 pounds of cargo sat exactly where it had been lashed at the test's beginning. "We need to understand the engineering principles at work here," Schmidt said. "This is not magic. This is applied physics and mechanical design. The Americans have solved a problem we did not realize we had." The 29th of November brought Hartmann and Schmidt to a detailed analysis session with senior Waffenamt officials in Berlin. They brought their test data, photographs, and, most importantly, the captured Jeep itself, now cleaned and prepared for technical demonstration. The conference room at Wehrmacht headquarters buzzed with skeptical officers who had spent careers believing in German engineering superiority. Hartmann presented the test results with careful neutrality, letting the data speak for itself. The Kübelwagen, 203 meters before immobilization. The Willys MB Jeep, 1,000 meters, full course completion with 800-pound cargo load. Weather conditions identical, terrain conditions identical, load weights identical. One of the assembled industrialists, a senior engineer from Volkswagen, who had worked on the Kübelwagen's development, interrupted. "This is not a fair comparison. The Kübelwagen was never designed for heavy cargo in extreme conditions. It is a reconnaissance vehicle, not a cargo hauler." Schmidt rose to respond, his voice carrying the authority of hands-on experience. "With respect, Herr Director, that is precisely the point. The Americans asked a different question when designing their light vehicle. They did not ask how to build the lightest, most efficient reconnaissance car. They asked how to build a vehicle that could do everything an infantry company needs in all conditions, with minimal support. The presentation continued through the afternoon. Schmidt detailed the Jeep's engineering features, explaining how each design choice contributed to operational effectiveness. The four-wheel drive system, while adding weight and complexity, provided traction that two-wheel drive could not match in adverse conditions. The solid axles, though offering inferior ride quality compared to independent suspension, were nearly indestructible and easily repairable in field conditions. Historical records from the Waffenamt archives show that the demonstration of the Jeep's capabilities caused considerable discomfort among the assembled officials. By late 1943, Germany was fighting on multiple fronts and logistics had become a critical vulnerability. The Wehrmacht desperately needed vehicles that could maintain mobility under the brutal conditions of the Eastern Front. Hartmann presented comparative production data that made the situation even more stark. According to Allied intelligence estimates, American factories had produced over 200,000 Jeeps by mid-1943. The vehicles were being shipped to Soviet forces, British Commonwealth armies, and American units worldwide. Germany, by contrast, had produced approximately 50,000 Kübelwagens since 1940. But the production numbers, as devastating as they were, represented only part of the story. The Jeep's real advantage lay in its operational philosophy. American military doctrine assumed that light vehicles would operate far from supply lines, maintained by soldiers with minimal mechanical training, carrying loads that might exceed their rated capacity. The Jeep was designed for this reality. According to technical documentation from the Aberdeen Proving Ground, where American vehicles underwent testing, the Jeep's rated payload was 800 pounds. But field reports from combat theaters showed vehicles regularly carrying twice that weight without mechanical failure. The overbuilt design, which seemed wasteful by German efficiency standards, provided operational flexibility that doctrine alone could not predict. Schmidt presented his analysis of the four-wheel drive system's advantages in deep mud. The key is constant traction, he explained to the assembled officers. In two-wheel drive, traction is limited to the driven wheels. If those wheels lose grip, the vehicle stops immediately. In four-wheel drive, losing traction at one axle still leaves the other axle pulling or pushing. He used a diagram to illustrate the point. In deep mud, weight distribution becomes dynamic. The vehicle pitches and rolls as it encounters obstacles. At any given moment, one axle might be more heavily loaded than the other. With four-wheel drive, the more heavily loaded axle, which has better traction, can compensate for the lighter axle. The system is self-balancing in a way that two-wheel drive cannot match. The 4th of December, 1943, brought Hartmann an unusual assignment. The Waffenamt wanted additional testing, this time directly comparing the Jeep against other German vehicles in its class. A Steyr 1500, a larger German military truck, would compete in cargo hauling tasks. A Kübelwagen with experienced drivers would attempt the mud course again, using optimal techniques. The goal was to determine if the Jeep's advantages were truly inherent to its design or simply the result of superior American driving tactics. The expanded testing took place over 3 days in early December. Winter had begun to set in, making the mud course even more challenging as freeze-thaw cycles created unpredictable variations in surface conditions. The Steyr 1500, a robust truck with four-wheel drive and significantly more power than either the Jeep or Kübelwagen, seemed like the obvious winner on paper. But battlefield performance, Hartmann was learning, rarely aligned with theoretical expectations. The Steyr, weighing nearly 3 times as much as the Jeep, simply sank deeper into the soft ground. Its wheels, designed for moderate off-road use rather than extreme conditions, became fouled with mud that packed into the tread patterns and turned them into smooth cylinders. The truck completed 400 meters of the test course before becoming hopelessly mired. The Kübelwagen, driven by Wehrmacht's most experienced test drivers using every technique learned from years of Eastern Front operations, performed better than in the first test. Careful throttle control, strategic momentum building, and expert weight transfer allowed the German vehicle to reach 320 meters before becoming stuck. It was a significant improvement, proving that driver skill mattered considerably. Then came the Jeep again, this time driven by a Wehrmacht mechanic who had never operated an American vehicle before. Hartmann wanted to eliminate the variable of driver experience to see if the Jeep's capabilities were accessible to average soldiers rather than just skilled operators. The mechanic, Gefreiter Hans Müller, received 30 minutes of instruction on the Jeep's controls before attempting the course. Müller approached the mud with visible nervousness, knowing that senior officers were observing his performance. He engaged four-wheel drive, as instructed, selected low range, and tentatively pressed the accelerator. The Jeep rolled forward, and Müller's nervousness gradually transformed into confidence as he felt the vehicle respond predictably to his inputs. The Jeep, driven by a near novice, completed the full 1,000-meter course. Müller's time was slower than Hartmann's, and his route less efficient, but the fundamental capability remained. The American vehicle simply worked. Regardless of operator skill level, it was engineered for accessibility, not exclusivity. Schmidt documented everything meticulously. His report, compiled over the following week, represented one of the most comprehensive evaluations of American light vehicle design produced by German military engineers during the war. The document was classified as secret, but its conclusions were unambiguous. The Willys MB Jeep represents a superior philosophy of military vehicle design for sustained operations under adverse conditions, Schmidt wrote in his summary. While German vehicles excel in specific performance parameters under optimal conditions, the American vehicle demonstrates superior operational effectiveness across the full spectrum of battlefield requirements. He detailed specific advantages. The four-wheel drive system provided traction that two-wheel drive could not match in mud, sand, or snow. The robust construction tolerated overloading and abuse that would destroy lighter vehicles. The simple maintenance requirements meant that units could keep Jeeps operational with minimal specialized support. The overbuilt components rarely failed catastrophically, and when they did, replacements were standardized and widely available. But Schmidt also identified what he considered the Jeep's greatest advantage, one that transcended mere mechanical specifications. The Americans designed this vehicle for mass production and mass deployment. Every component was chosen for availability and manufacturability. Nothing on the Jeep required specialized skills or rare materials to produce or repair. The design philosophy, Schmidt concluded, reflected a fundamental understanding of modern industrial warfare that Germany had failed to fully grasp. In mechanized war, he wrote, operational readiness rates matter more than peak performance. A force equipped with adequate vehicles maintained at 80% readiness will defeat a force equipped with superior vehicles maintained at 30% readiness. The 19th of December brought a high-level briefing at which Hartmann and Schmidt presented their findings to Wehrmacht operational planners. The timing was critical. The Eastern Front was consuming vehicles at an unsustainable rate, and the autumn mud had left thousands of German vehicles stranded or damaged. The military needed solutions, and needed them urgently. General Heinz Guderian, the Inspector General of Armored Troops, attended the briefing personally. Guderian had built his reputation understanding mechanized warfare's operational requirements, and he grasped immediately what the Jeep represented. This is not merely a vehicle, Guderian said after hearing the presentation. This is a philosophy of logistics. The Americans have understood that in mobile warfare, the decisive factor is not the capability of individual vehicles, but the operational readiness of the force as a whole. Guderian asked Schmidt a pointed question. If Germany were to design a new light vehicle today, learning from this American example, what would you change about our current approach? Schmidt answered without hesitation. First, we would accept additional weight to gain four-wheel drive and stronger components. Second, we would simplify every system to enable field repairs by non-specialists. Third, we would design for overloading rather than optimal loading, accepting that battlefield requirements always exceed peacetime specifications. Fourth, we would standardize components across multiple vehicle types to reduce supply chain complexity. Guderian nodded slowly. You have described precisely what we should have built 3 years ago. Unfortunately, we now lack the resources and time to implement such changes. Our industrial capacity is fully committed to current designs, and retooling would take months we do not have. The meeting concluded with acknowledgement, but no action. Germany's military vehicle fleet was already determined by decisions made years earlier. The Jeep's lessons came too late to alter production, though they would inform thinking about post-war vehicle development, assuming Germany survived to have a post-war period. Hartmann spent the final weeks of 1943 writing supplementary reports and conducting additional tests on the captured Jeep. He tested its towing capacity, finding it could pull a small artillery piece through mud that stopped German trucks. He tested its maximum range, discovering it could operate for over 250 miles without refueling. He tested its maintainability, deliberately inducing failures to see how quickly they could be repaired with basic tools. Every test reinforced the same conclusion. The Jeep was not perfect, but it was profoundly effective. It carried troops, equipment, ammunition, wounded soldiers, and supplies across terrain that stopped other vehicles. It absorbed punishment and kept running. It required minimal maintenance and could be repaired by any mechanically inclined soldier with a wrench and hammer. According to records from the United States Army Center of Military History, the Willys MB Jeep was shipped to Allied forces worldwide in quantities that dwarfed German light vehicle production. Over 360,000 Jeeps were built by Willys, with another 280,000 produced by Ford under license. These vehicles became the iconic symbol of American motorization, appearing in every theater from the Pacific Islands to the European forests. For German soldiers, the Jeep became a prized capture, more valued than many heavier vehicles. Wehrmacht units repainted captured Jeeps with German markings and pressed them into immediate service. Some were sent to the rear for official evaluation, but many remained with the capturing units, kept operational through battlefield necessity. The 7th of January, 1944 marked the official conclusion of the Jeep evaluation program. Hartmann was reassigned to other duties, applying lessons learned to improve German vehicle maintenance procedures. Schmidt returned to vehicle design work, carrying with him a newfound respect for American engineering pragmatism. The captured Jeep at Kummersdorf remained in service as a test vehicle, used to train German mechanics in maintaining and operating American equipment. By late 1944, captured American vehicles had become common enough in German service that such training became operationally necessary. The vehicle that had been an object of study became a tool of necessity as Germany's own production faltered. Oberleutnant Werner Schmidt, after the war's end, found himself in American custody. Ironically, he spent his time as a prisoner of war assigned to a maintenance section where he helped keep American vehicles operational. His expertise with the Jeep, gained through months of study, made him valuable to his captors. In conversations with American mechanics, Schmidt shared his wartime evaluation findings. The Americans were surprised and somewhat amused to learn that German engineers had studied their Jeep so thoroughly and rated it so highly. "We knew it worked," one American sergeant told Schmidt, "but we didn't know it was anything special. It's just what we had." That casualness, Schmidt realized, was itself revealing. The Americans had built a vehicle so reliable, so capable, that they took its performance for granted. What seemed remarkable to German engineers was unremarkable to American soldiers because they had never known anything less capable. Their entire military logistics system was built around vehicles that simply worked in all conditions. Historical research conducted after the war confirmed the Jeep's decisive impact on Allied mobility. Studies analyzing World War II operations found that American forces maintained significantly higher vehicle operational readiness rates than German forces across all theaters. This advantage in sustained mobility translated directly into operational tempo, allowing American units to maintain offensive pressure while German forces were often immobilized by vehicle breakdowns and supply failures. According to military historians, the Jeep's four-wheel drive capability was particularly decisive in the European theaters' autumn and spring mud seasons. While German forces waited for roads to become passable, American units continued operations using Jeeps to maintain supply lines and communications. This sustained mobility, multiplied across divisions and armies, created cumulative advantages that no amount of tactical brilliance could overcome. The 23rd of March 1945 brought Klaus Hartmann to a muddy field near Berlin as Soviet forces approached the capital. He was part of a desperate rearguard, trying to keep supplies moving to units making last-ditch defenses. The irony was not lost on him when a captured American Jeep, repainted with German markings, became his primary vehicle. The Jeep, now over a year into German service, still ran reliably. Its odometer showed over 40,000 kilometers, traveled across some of the worst terrain in Europe. It bore scars from its service, dented panels and cracked glass and hasty repairs, but its engine still started reliably and its drivetrain still functioned smoothly. Hartmann used the Jeep to evacuate wounded soldiers from forward positions, its 800-pound payload capacity now filled with broken men rather than ammunition. He drove it through mud that would have stopped any vehicle in the Wehrmacht's original inventory, the four-wheel drive, pulling through obstacles that the war's beginning German forces would have considered impassable. The 8th of May, 1945, brought Germany's surrender and the war's end. Hartmann, like millions of other German soldiers, found himself transitioning from combatant to prisoner of war and eventually to citizen of a defeated nation. The captured Jeep that had carried him through the war's final weeks was returned to Allied control. Just another piece of military equipment being sorted and redistributed in the chaos of Europe's liberation. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. In post-war years, Hartmann found work in Germany's rebuilding automotive industry. He brought with him lessons learned from studying the American Jeep, insights about robust design, operational flexibility, and designing vehicles for real-world conditions rather than ideal specifications. These principles influenced the development of German post-war vehicles, contributing to a reputation for reliability that would eventually rival and in some cases exceed American manufacturers. Schmidt, released from prisoner of war status in 1946, returned to automotive engineering with a changed perspective. He spent 30 years designing vehicles for Mercedes-Benz, where he became known for advocating robust, oversized components and generous safety margins. When asked about his design philosophy, he would sometimes tell the story of a captured American Jeep that carried 800 pounds across mud so deep it had seemed impassable. The Willys MB Jeep that German engineers had studied so intensively at Kummersdorf did not survive the war. It was probably destroyed in the final battles around Berlin, or perhaps captured and scrapped by Soviet forces, or simply abandoned and forgotten in the chaos of Germany's collapse. But the lessons it taught lived on, influencing a generation of German engineers who had learned to respect American pragmatism. According to automotive historians, the Jeep's influence extended far beyond its military service. After World War II, the vehicle's design inspired civilian four-wheel drive vehicles worldwide. Willys converted the MB into the civilian CJ model, launching the sport utility vehicle category that would eventually dominate American automotive sales. Other manufacturers, including German companies, developed their own interpretations of the Jeep concept. The principles that made the Jeep effective in war, robust design, four-wheel drive traction, operational simplicity, proved equally valuable in peace. The vehicle became a tool for farmers, construction workers, rural medical services, and anyone needing reliable transportation across difficult terrain. The wartime engineering that German engineers had found so impressive became peacetime practicality that millions of civilians found indispensable. For Werner Schmidt, the Jeep represented a fundamental lesson about engineering that stayed with him throughout his career. Excellence in design is not measured by sophistication or theoretical performance, he would tell his engineering students in later years. Excellence is measured by how effectively a design solves the real problems its users face under actual operating conditions. He would describe the Kummersdorf tests, the Kübelwagen, stopping at 200 meters while the Jeep completed the full course. The story became a parable about the difference between designing for elegance and designing for effectiveness. We Germans built a vehicle that was lighter, more fuel-efficient, and more comfortable than the American Jeep. And we lost the war partly because their crude, heavy, simple vehicle worked better where it mattered most, in the mud and chaos of actual combat. The 1st of June, 1973, brought an unexpected reunion. The German Army Museum in Dresden, now in East Germany, was preparing an exhibition on World War II military vehicles. Schmidt, living in West Germany, received an invitation to speak about his wartime evaluation work. The divided Germany of the Cold War made such contact unusual. But the museum's historical mission transcended politics. At the museum, Schmidt encountered a restored Willys MB Jeep brought from Soviet military surplus stocks. He approached it slowly, his hand reaching out to touch the hood, memories flooding back across 30 years. The museum curator, noting his emotional reaction, asked if Schmidt had personal history with this type of vehicle. "I spent months studying these machines," Schmidt explained, "learning their secrets, understanding why they worked so much better than our own designs. This vehicle taught me more about engineering than a decade of university education." The curator arranged for Schmidt to give an impromptu lecture to museum visitors that afternoon. He stood beside the Jeep, now elderly but still sharp in memory and technical understanding, explaining how a simple American vehicle had outperformed German engineering during the war. His audience included students, veterans, and engineers, all listening to a first-hand account of discovering an opponent's superiority. Schmidt concluded his lecture with a reflection that resonated with his Cold War audience. The Jeep's lesson was not that American engineers were smarter than German engineers. The lesson was that they asked better questions. They asked how to build a vehicle that would keep working despite abuse, despite poor maintenance, despite overloading and combat damage. We asked how to build a vehicle that performed optimally under ideal conditions. In war, ideal conditions never exist. Klaus Hartmann, unable to attend the museum event due to health issues, sent a written statement that the curator read to the assembled audience. The 800 pounds that the Jeep carried across deep mud represented more than cargo. It represented industrial capacity, pragmatic design, and a philosophy of engineering that prioritized effectiveness over elegance. When I drove that captured Jeep through Berlin's ruins in April of 1945, I understood that Germany had lost not just a military contest, but a contest of industrial philosophies. The museum exhibition included technical diagrams that Schmidt had prepared during his original evaluation, salvaged from archived Wehrmacht documents. The drawings showed the Jeep's four-wheel drive layout, its suspension geometry, its load distribution. To modern visitors, the technology seemed ancient, almost quaint. But Schmidt knew that these simple mechanical solutions had been revolutionary in their proper context. After the lecture, a young engineering student approached Schmidt with a question. "Do you think Germany could have won the war if we had designed vehicles like the Jeep from the beginning?" Schmidt considered the question carefully before responding. "No," he said. "Vehicle design was just one factor among many. But if Germany had approached all its industrial production with the philosophy embodied in the Jeep, designing for reliability and mass production rather than for peak performance and precision, the war would certainly have lasted longer and cost more lives on all sides. In that sense, I am grateful we did not learn the lesson until too late." The 29th of September, 1987, brought Oberleutnant Werner Schmidt to the end of his long life. He died peacefully in Stuttgart having spent 40 years in Germany's post-war automotive industry. His obituary in professional engineering journals mentioned his contributions to vehicle suspension design and his role in establishing reliability standards that became German automotive industry norms. But Schmidt's family, sorting through his papers after his death, found something that the public obituaries had not mentioned. A detailed technical report, carefully preserved in a locked file cabinet, documented his 1943 evaluation of the captured American Jeep. Handwritten notes in the margins showed that Schmidt had continued thinking about the vehicle's design lessons throughout his career. One note, written in Schmidt's careful engineering script, summed up the Jeep's significance. This vehicle taught me that effectiveness trumps efficiency, that robustness trumps lightness, and that simplicity trumps sophistication. These lessons guided every vehicle I designed for the next 4 decades. I owe my career's success to studying an enemy's machine and having the humility to recognize its superiority. The captured Jeep, long since destroyed or disappeared into history's chaos, lived on through the engineers it had influenced. Its 800-pound load across deep mud became a benchmark, a standard against which other designs were measured. The Germans had studied it, tested it, documented it, and learned from it, even though those lessons came too late to affect the war's outcome. Historical analysis, conducted in the decades after World War II, consistently identified vehicle mobility as a critical factor in Allied victory. American forces maintained offensive tempo that German forces could not match, partly because American vehicles kept running while German vehicles broke down. The Jeep, multiplied by hundreds of thousands across all theaters, represented a decisive advantage that no amount of tactical skill could overcome. The humble light truck that German engineers had found so remarkable became one of the war's most influential machines, not because it was sophisticated or advanced, but precisely because it was simple, rugged, and effective. It embodied a philosophy of engineering that prioritized working over impressing, effectiveness over elegance, battlefield reality over theoretical perfection. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.